Chapter 7, Trig Identities. In this chapter, we will review basic trig identities, verifying trig identities, sum and difference identities, double angle identities, and solving trig equations. Basic trig identities, Section 1.
Okay, so there are three basic trig identities. The first one and the most commonly used one is sine squared theta plus cosine squared theta equals 1. Second one is tangent squared theta plus 1 equals secant squared theta. And the last one is 1 plus cotangent squared theta equals cosecant squared theta.
Chapter 7.1, Reciprocal Identities.
Okay, to find the reciprocal identities, we can first try to find the reciprocal of sine. Sine theta is defined as y over 1 or just y. The reciprocal of sine is cosecant theta, which equals 1 over y. Pretty simple. You just switch from y over 1 to 1 over y. The reciprocal identities are defined as such. Sine theta will equal 1 over cosecant theta. There are 6 reciprocal identities to define these. The first one is sine theta equals 1 over cosecant theta. The second one, cosecant theta equals 1 over sine theta. The next one, tangent theta equals 1 over cotangent theta. The next one, cosine theta equals 1 over secant theta. Secant theta equals 1 over cosine theta. And the last one, cotangent theta equals 1 over tangent. Okay, so the first example that we're going to do involves the Pythagorean identity as well as the reciprocal identity combined into one equation. The question asks to simplify sine x plus sine x cotangent squared x. The first thing that we have to do in this equation is factor out the sine. So you take out the sine, and then the sine in the original equation becomes a 1, and it becomes 1 plus cotangent squared x. After that, you use the Pythagorean identity, which is 1 plus cotangent squared x equals cosecant squared x. So that would be sine x times cosecant squared x. And to do this, after this, you have to use the reciprocal identity, which equals sine x times 1 over sine squared x. And then after that, you'll get 1 over sine x, and that is equal to cosecant x. And that's the answer.
Here is example 2.
So here we have a verifying problem, and we want to solve the right side because it looks more complicated and looks easier to solve for the left side. So first step would be to put everything in terms of cosine and sine. So that would make the equation cosine x over 1 minus sine x over cosine x plus sine x over 1 minus cosine x over sine x. And the next step would be to get the fractions out of the denominators. So you times the first term cosine x over cosine x and the second term by sine x over sine x. So that would make the equation cosine squared over cosine x minus sine x plus sine squared x over sine x minus cosine x. And then the next step to that would be to make the denominator same. So you times this first term by -1 to make it equal, to make the denominator equal to the second term. So that would get negative cosine squared x over sine x minus cosine x plus sine squared x over sine x minus cosine x. The next step to be that for that equation would be to just add these two fractions since they have the same common denominator. So that would make the equation sine squared x minus cosine squared x over sine x minus cosine x. And that top numerator you are able to factor into sine x minus cosine x times sine x plus cosine x. And since a term in the denominator and the numerator are the same, you can cross that out since it will equal 1. So what you're left with is sine x plus cosine x equals sine x plus cosine x.
Chapter 7.3 Sum Identities.
In this chapter, we'll be learning about the sum identity for the cosine function, sine function, and the tangent function. First, let's start off with the sum identity for the cosine function. You have cosine alpha plus beta equals cosine alpha minus negative beta, which equals cosine alpha cosine negative beta plus sine alpha sine negative beta. And that equals cosine alpha cosine beta plus sine alpha times negative sine beta, which equals cosine alpha cosine beta minus sine alpha sine beta. And then, after you derive the equation, you have the sum identity for the cosine function. Cosine alpha plus or minus beta equals cosine alpha cosine beta minus plus sine alpha sine beta. Next, we'll be learning about the sum identity for the sine function. So, we can derive the sum identity for the sine function from the cosine function. You have to replace alpha with pi over 2 and beta with s in the identities for the cosine alpha plus or minus beta. First, you'll have cosine pi over 2 plus s, which equals negative sine s. And then you also have cosine pi over 2 minus s, which equals sine s. Then you have to replace the s with pi over 2 plus s in the equation for cosine cosine pi over 2 plus s, and with the pi over 2 minus s in the equation for cosine pi over 2 minus s to obtain the following equations. So you have cosine s equals sine pi over 2 plus s. And then you also have cosine s, which equals sine pi over 2 minus s. Then you have to replace the s with alpha plus beta in the equation for cosine pi over 2 minus s to derive the identity for the sine function. So you have cosine pi over 2 minus alpha plus beta, which equals sine alpha plus beta. Then you have cosine pi over 2 minus alpha minus beta. That equals sine alpha plus beta. Then you use the identity for the cosine alpha minus beta function, and you get cosine pi over 2 minus alpha cosine beta plus sine pi over 2 minus alpha sine beta, which equals sine alpha plus beta. And then you get sine alpha cosine beta plus cosine alpha sine beta, which equals sine alpha plus beta. And then in the end, you get the sum identity for that sine function. Sine alpha plus or minus beta, which equals sine alpha cosine beta plus or minus cosine alpha sine beta. And then, using both the sum identities for the cosine function and the sine function, you can find the sum identity for the tangent function. And the sum identity for the tangent function is tangent alpha plus or minus beta, which equals tan alpha plus or minus tan beta over 1 minus plus tan alpha tan beta.
Chapter 7.4 Double Angle Identities.
In this chapter, we'll be learning about the double angle identities for the sine, cosine, and tangent functions. So, let's go on to the double angle identity for the sine function. It is sine 2 theta equals 2 sine theta cosine theta. Now onto the cosine function. The first one is cosine 2 theta equals cosine squared theta minus sine squared theta. The second one is cosine 2 theta equals 2 cosine squared theta minus 1. The third and last one for cosine is cosine 2 theta equals 1 minus 2 sine squared theta. Now, onto the double angle identity for the tangent function. And it is tangent 2 theta equals 2 tangent theta over 1 minus tangent squared theta. And those are your 5 double angle identities. Now, let's try one example. So, let's say if sine theta equals 2 over 3 and theta has a terminal side in the first quadrant, find the exact value of each function. So, the function that we're going to do right now is sine 2 theta. So, first, you need to use the double angle identity for sine 2 theta. But first, we're going to have to find cosine theta. So, use the sine and cosine formula, which is sine squared theta plus cosine squared theta equals 1. And then you have to plug in 2 over 3 for sine theta. 2 over 3 squared plus cosine squared theta equals 1. And then, after you square the 2 over 3 and subtract that by 1, you get cosine squared theta equals 5 over 9. And then, to get cosine theta, you have to square root both sides. So we're going to square root both sides, and you get cosine theta, which equals root 5 over 3. And now you have to find sine 2 theta. So use the double angle identity for sine, which is sine 2 theta equals 2 sine theta cosine theta. And then plug in what you have for sine theta and cosine theta. So you have 2 and sine theta equals 2 over 3. So 2 times 2 over 3 times cosine theta, which is root 5 over 3. And the answer to that is 4 root 5 over 9. And that is your answer for sine 2 theta.